This video will cover the least squares network adjustment of the total station observations. Shortly, some GNSS derived coordinates will be introduced, but before that, the data can be checked within itself as it was taken in the field to highlight any issues or errors that might be present within the data. Just a reminder on the settings for the network adjustment. In project settings, so for the network adjustment, in the general section, the input for terrestrial data, total station data, can be the mean angle results from rounds of angles, or it can be individual observations, whichever your preference is. The default standard errors for total station data, the source for those can be the precision estimates in the imported raw data file, and the source for centering errors is generally configured within the project settings. So if we look at the total station section here, if you did want to specify your own default standard errors for the total station measurements, that would be done here rather than using the data in the imported raw files. And the centering errors and height measurement error estimates are set here. Whilst in the project settings, it's also worth pointing out that the default standard error is a very small value, so it's so small by default that it almost acts as a constraint within a network if there is an azimuth present, rather than it actually be specified as a constraint. So I'll close up the project settings and proceed to the survey ribbon and adjust network. I'm going to clear any previously set information, so this would be the default starting scenario. Only one point has control quality in this data set, and that's L2, so it's possible to constrain using the coordinates for L2. As a reminder, if we look in Project Explorer under L2, we can see here's the keyed in coordinate in a local grid system and the azimuth value that was entered in the field at the time of survey. So the first form of adjustment would be a minimally constrained or free adjustment, so nothing constrained or just one constraint in place. So as I'm going to constrain L2 anyway, I will tick the box to constrain it in 2D only, and then adjust, and the network reference factors computed, chi-square test is also calculated, and the results will be in the network adjustment report. It's possible to open here. So constraint summary. Easting and northing error estimates for each of the points adjusted in the network. Error ellipse dimensions here, and then the results either for the rounds of angles or the individual measurements as per the settings, with the standardized residual column here on the right. Just to mention as well that there is a live link between the report and the data, so this observation at the top must contain within it the highest standardized residual, and looking across into the column here we can see that it's for the delta elevation, and this is an observation from point L10 to L2, or the mean results of a round of angles from L10 to L2. So if I click on the name of the round of angles in this case, where that data sits within the project is highlighted. So this will be a closing shot in all probability from L2 to from L10 to L2. So just checking that there's no outliers flagged. Nothing is flagged in red. Outliers would be flagged in red at the top of the table. There's nothing showing there. So I'll proceed onwards to the next round of adjustment. So the network reference factor is below 1 by quite some distance. If we look at the weighting tab, you can see that the measurement component that's furthest away from 1 is the horizontal angles. So if desired, it's possible to, in this case, decrease the amount of anticipated error or scale down the amount of anticipated error in the adjusted angles by pressing the scaler button here. Having done that, adjust again. Get a new network reference factor calculated. Chi-square test has still failed. So go to the next component, which is the slope distances, and adjust again. And the network reference factor is creeping close to 1. Chi-square test still failed. And finally, the vertical angles. So having done all of those, the network reference factor is in the vicinity of 1 and the chi-square test has passed. I can do another check on the report. It's unlikely any outliers would creep in at this stage of adjustment, and there aren't any showing here. So that's just with one constraint. As I said earlier, the default standard error value on an azimuth is so tight by default that it almost acts as a constraint without being specified as a constraint. But we can set that azimuth specifically as a constraint using the Add Azimuth Constraint button here on the Constraints tab. So I'll just go to this button, and that would be from point L2 to point L1. So we know that that value from reviewing the imported data earlier is currently set to 0 degrees. So having added any additional constraints, there is only one in this example. There's no additional coordinates for the data set at this stage. Press adjust. So chi-square test still passed, and if I select all the points in Project Explorer, we can see graphically the estimated easting, northing and elevation error values. So the network, none of the constraints were set in elevation, just in 2D, as from this data set it's really only the eastings, northings that are of interest, as the elevations for these stations will be computed from digital level data. But if they were to be included, then it's a case of just constraining the elevation component. That's required as part of the adjustment as well. So that final iteration of the network adjustment report could be saved, copied to a Word document, or printed to a format such as PDF. At this stage, we can say that the raw field observations fit together within themselves with no blunders, as might be indicated by the warning flags with the 20 and 50 mil default convergent criteria, and the network adjustment has adjusted with a chi-squared test pass with no outliers. So given that we know that the data is good, we could proceed to the next stage of adjustment, which is to introduce some coordinates calculated via the GNSS post-processing.